So this is the triangle inequality theorem, which states that the sum of any two sides of a triangle must be greater than the measure of the third side. So if you can see the figure, we have sides A, B, and C. So for us to make a triangle out of the combination of numbers, we need to consider that the sum of any two sides must always be greater than the remaining side. So in this case, we have A plus B is greater than C, and then B plus C is greater than A, and then A plus C is greater than B. Alright, so let us try to draw a triangle out of this set of numbers. So can we draw a triangle out of this set of numbers for the sides? We have 5, 10, and 12. So according to the triangle inequality theorem, we should satisfy the three given conditions, that A plus B should be greater than C, B plus C should be greater than A, and A plus C should be greater than B. So if we are going to label our numbers corresponding to the sides, so 5 is our side A, 10 is our side B, and 12 is our side C. We need to ensure that the conditions given must all become true for the triangle to be constructed. So if we say that A plus B should be greater than C, then that is 5 plus 10 greater than C. So 5 plus 10 is 15. So 15 is greater than 12. So this is true. So the next one is B plus C should be greater than A. So our B is 10 and our C is 12. Then it should be greater than A. So 10 plus 12, that is 22. It should be greater than A. Okay, so the value of A is 5. So 22 is greater than 5. So this is true. So the last condition is A plus C should be greater than B. So we have A is 5 plus C, that is 12, greater than B. So 5 plus 12, that is 17, greater than, the value of B is 10. So this is again true. Now, we go back to our question. Can we draw a triangle out of this set of numbers for the sides? Since we satisfied all of the conditions having true, then we can say that yes, we can draw the triangle out of this set of numbers 5, 10, and 12. Alright, so we have another problem. So we have the combinations 3, 4, and 10. So can we draw a triangle out of this set of numbers for the sides? So again, we will go back to our condition. So the first thing is to label our sides. So A for 3, B for 4, and C for 10. And then we first solve for A plus B should be greater than C. So A is 3 plus our B is 4, and it should be greater than, the value of C is 10. So this is 7 greater than 10. So this is false. Alright? So let's see. The next one is B plus C is greater than A. So our B is 4 plus C is 10 greater than our A is 3. So 4 plus 10 is 14 and it is greater than 3. So this one is true. And the last one is A plus C is greater than B. So A is 3 plus 10 greater than 4. So 13 is greater than 4. So this is true. But according to the triangle inequality theorem, that the three conditions must be satisfied. So since we have a false here, so we can say that 3, 4, and 10 cannot be the sides of the triangle. So we can say that this is no. Okay, so let's practice. Find the range of possible measures for the third side x given that the two side lengths are 2 and 7. So we are going to find the value of x in a range or in an interval in which it can become a possible side of the triangle. So what we're going to do, the easiest method to do this is to first add the two numbers together. So we have 7 plus 2, so that is equal to 9. And then subtract the two numbers. 7 minus 2 is equal to 5. Then we can write this in terms of a range in such a way that x is in the middle and you have the two values. So we have 9 as the maximum number and 5 as the minimum number. So x is less than 9 but greater than 5. In the second example, let's again look at this. Find the range of possible measures for the third side x given that the two side lengths are 12 and 8. So we can just simply add and subtract. So we have 12 plus 8, that is equal to 20. And then 12 minus 8, that is equal to 4. So our range would be that x is less than 20, but that is greater than 4. Alright, so let's practice more. Two sides of a triangle have the following measures. Find the range of possible measures for the third side x. So we have 2, 7, 8, 3, 5, 9. So we can just actually do this mentally. So we place all the values of x in the middle. So the first thing that we're going to do is to add, and the next is to subtract. So 7 plus 2, that is equal to 9. And then 7 minus 2, that is equal to 5. For the next 8, 3. So the highest number would be 8 plus 3 is 11. Then 8 minus 3, that is equal to 5. And for the last, 5 plus 9, that is 14. And then 9 minus 5, that is equal to 4. So that's it. That's how we find the range of possible measures for the third side x. Thank you for watching.